Alright, welcome to the video on speed and velocity number 2. I just thought I'd make another one with some more examples to explain the difference between these two concepts, which get used incorrectly most of the time in everyday experiences. They use them interchangeably, which really they're not the same thing. Okay. In a previous video, you probably know now the difference between a scalar and a vector quantity. Scalars only have a magnitude, and vector quantities have a magnitude plus direction. So speed is a scalar. Okay, you're traveling at 100 kilometers per hour, 7 meters per second, 52 miles per hour. Whatever the unit that you use, it only has a magnitude value. It does not have a direction. That's speed. Before I get onto velocity, let's just talk a little bit about average and instantaneous speed. Let's say you're in your car driving to school. Okay. Now, when you're in the car, a very modern looking car like so, and you're driving to school, you drive along one road and then you turn left, you drive another long road, you stop at a set of lights, okay, you then turn right, turn left, go this, go round a roundabout, go here, stop to get some petrol, okay, and then you end up at school. Now, over that trip, you have covered a certain distance and in a particular time period, and so you have had a speed. I mean, your speed was 0 at the set of lights here. Your speed was 0 when you're putting petrol in. You started your speed at 0 and you ended your speed at 0. But you could have been going this, quite fast along here. Let's say 60 kilometers an hour in a built-up area. You might have hopped on the highway and gone 110 for a little bit. Hopped off the highway. Around a roundabout, you're going fairly slow around there. So your speed is going up and down. But on average, you have an average speed. So your average speed is the distance that you travel divided by the time it takes. Okay, so when you're working out the speed of a journey, it's the average speed. Now notice I've used S here for speed. Okay, we can also do it with V, which stands for velocity if we're talking about a vector, but we can also just use normal V to represent the magnitude value of speed, right? And so at the moment, V with no arrow at the top means speed, okay? Because let's think about it for a second. If I was to travel in a straight line, let's say I was to travel at 60 kilometers per hour, I was ignoring direction. If I'm ignoring direction, my value, my magnitude is exactly the same, 60. So really, we can use the same symbol V with no hat on the top to represent speed. And then when we want to talk about velocity and include a magnitude, we then put a hat on the top there to say, now that's velocity, right? So you might see that in different textbooks as well. But the formula is the same, okay, for if I'm using the V here without a hat, okay? So we've got distance divided by time. The units can be meters per second, kilometers per hour, okay, this meters per second, that's the preferred standard international SI units, okay, meters per second. So when you do your values and you put your values into your equation, you've got to make sure that the units agree, okay. So that's a little trick with a lot of questions, is they might give you the distance in, let's say, meters, and then the time in hours, and you can't say there's meters, hours here. You have to either convert the hours into seconds, so you've got meters per second, or you convert the meters into kilometers, so you've got kilometers per hour, depending on what they specifically ask in the question. So just watch out for that little trick. So that is an average speed. What's your instantaneous speed? Your instantaneous speed is the rate of change of speed at a particular point in time, at a very, very, very small time interval. And you'll learn more about that when you're doing senior maths, right? So it is the rate of change of your speed in a very small time frame. And just think of it as it's your speed at that second, right? So when you're in your car and you're looking at your speedometer, that shows you your speed at that moment in time, your instantaneous speed. So back to our trip here, if you're traveling at 60 kilometers per hour here, then you hit the freeway and it's 110 kilometers per hour, then your instantaneous speed at a particular second is 60. Then you, of course, increase your speed, so you accelerate. but then you're hitting 110. At that moment in time, it's 110. That's your instantaneous speed. But your average speed is for the whole trip. Okay, so that's speed. Well, velocity is related to a direction. So remember, it's a vector quantity. It's a vector quantity. It has magnitude plus a direction. The formula for that, let's just rub this out here. The formula for velocity is your displacement divided by time. That is your change in displacement. The little triangle there means change. So your change in displacement divided by time. We know that since displacement is a vector quantity, therefore our velocity must be vector. So our velocity is equal to our displacement over time. Or, of course, if you want to use d instead of s, our vector displacement divided by time. So velocity is a vector quantity. Now here's a question for you. Can you have the same velocity if you're traveling in a circle at constant speed? Can you travel at 10 kilometers per hour? Your speed's not changing, but is your velocity changing, or is it the same? I want you to think about that, because in the next video on acceleration we'll answer that question, but I will answer that question next time you're in class. Can you change your direction and have a constant speed? What happens to your velocity? Is it changing or is it the same? All right, let's do a question. Let's rub this off, do a question. All right, here we go. 2 questions to finish off. The first one, a skateboarder travels 350 meters in 52 seconds. What is his average speed? Okay, well, of course, you remember that speed is equal to distance divided by time. So the distance here is 350 meters. The time he takes is 52 seconds. And meters per second is, of course, the SI unit, so that's perfectly fine with our numbers there. So 350 divided by 52 gives you 6.73 meters per second. So that's how fast they're traveling. Simple. Let's have a look at the second one. A motorbike travels at 42 kilometers per hour for 28 minutes. How far has it traveled? Okay, well, let's write our formula here. Speed is equal to distance divided by time. How far has it traveled? So the time is the unknown here. So we want to make time the subject of the equation. So d divided by t. So since the last step was divide by, we times both sides by t. So we times by t here, and we times by t. They cancel out. So the distance, that is how far, is equal to speed times time. All right, let's do that now. Distance is speed times time. Well, let's have a look. 42 kilometers per hour minutes. Problem. There's a unit problem, so we need to convert this into either this needs to be converted into hours, or this here needs to be converted into meters per second. You can do either, all right? What we're going to be doing is we're going to convert this into hours here. Okay, so we have, if I just write this up here, time is 28 minutes times, and what we're going to be looking at here is 1 hour has 60 minutes in it. So the minutes cancel, and so that's basically saying 28 divided by 60, and that will give us 0.46 of an hour. Okay, so now we've got it in terms of hours. So the distance here, the speed, was 42 kilometers per hour times the time, which is 0.46 hours, right? The hours cancel, which means we have 42 times 0.46, and that is 19.6 kilometers. So that is our answer there. Okay, so the first thing you've got to make sure is to get this correct here, right? Converting from 28 minutes into hours. Another way of thinking about that, of course, is you can say, okay, well, 1 hour is the same as 60 minutes. And then you can go, okay, well, to go from 1 to 60, I've got to times by 60. And to go from 60 back to 1, I've got to divide by 60. And so we wanted to go from minutes to hours, so we need to divide by 60. And that's what we did. 28 divided by 60 equals 0.46. It all depends on what makes sense to your brain. Okay, there's 2 questions. Hope that makes sense. See you in this video.